Hello everyone. So today we are going to solve a very interesting problem number 383, ransom note. And this problem says that we have been given two strings, ransom note and magazine. Return true if ransom note can be constructed by using the letters from magazine and false otherwise. Each letter in magazine can only be used once in ransom note. So we have examples like this. So we have a magazine string. Let's say it is A, B, and C, and the ransom note is double A, C. So we can see that we can create this ransom note by picking one letter A from magazine, another letter A, and another letter C from the magazine. So this is how we can create the ransom note, and we can return true. And for another example, if it is example, let's say the another example is A, B, and D, then in that case we'll return false because we don't have a letter D in the original magazine string. So the my approach for this problem would be I would be using one hash set to create to create the hash set for magazine. So for this I will create one magazine hash set that will give me the count of letters in the magazine. So it will say that there are two A's, one B, and one C. Similarly, I will create one set for the random note which will have the letters of the random note. So this I'm doing for A and C. So that would say A is 1, A is 2. So this is 2, C is 1. And for another test case which is false, I'll create the another count R which would say as like this, that this is A is 2, and then A is 1, B is 1, and D is 1. So here is the trick in the algorithm that I'm going to do. Now the characters that are in my ransom note, if they are not present in the original magazine string, then I will add them in my magazine set as well. So that way when I'm going to traverse at the last, I can check whether this string, there are these characters of character count of each character in my set is there or not between both the uh, between both the hash sets, and if they are, then we'll return true. If they are not, then we'll return false. I hope you have understood my algorithm, and I'm going to show you different approaches of how I can implement this up algorithm into the coding part. And without further ado, let's dive into the problem and see how we can code this algorithm up. So the first way is I'm showing you using this is approach 1, this is approach 1, and where here I'm going to use the inbuilt function. So using inbuilt library, and then I'm will convert those into the how that without inbuilt library can we use this, can we solve this problem. So first I want to create the set for the magazines characters, so that I'm going to create the hash set with the magazine. Similarly, I'll create one random set with the random string. So I'm using the counter function for creating this set for magazine and note. And now we'll check that for all the characters in the lowercase English letters between meaning from A to Z. So for characters in ASCII dot lowercase, so this basically returns the all the letters in the English, all the English characters in English language. And here we are going to check whether the count for the character in the ransom note is less than or equals to the character present in the magazine set also. So if it is less than or equals to, then we can create this, otherwise we can't. That's the logic which I discussed. And now let's run our solution and see how it performs for different test cases. So lowercase character is not present, so it is present in the library called string. So we are going to import the string. So from string we are going to bring ASCII 2 underscore lower. It has that function, you can check this. So this has been accepted. And now what if I don't want to use all these things using counting algorithm? I'm going to show you this problem using counting algorithm that I'm going to write the same problem but without using the inbuilt functions that we just use. So that would, I think, would be a better way of solving this problem. So what we'll do is we'll define our own all the characters, so that are basically A B C D E F G H I J K L M N O P Q R S T U V and W X Y Z, and we want this to be in the string format, and we are going to create our own S set for the magazine. So for characters in magazine we are going to add that into our hash set, and if it is not present then we'll name it as, we'll update the count as 0, and if it is there then we'll add 1 to it to get the count of that character. Similarly, we'll create the ransom set for the ransom string, ransom note string. So for characters in ransom note, what you want to do is we can just create same thing that we are doing in the character, in the hash set of ransom note. So this is magazine, this is ransom note dot get the character, and if it is not there, then default as initialize it as 0, and otherwise add 1 to it and get the count. And now the same thing that we want to check, that whether the count of the each character occurrence in ransom note has enough characters in magazine. So we'll compare for both characters from the character set, from the character string that we declared for every character. So that is for each character in the character string that we declared on the top. So this is the uh, I would say expanded approach of the previous algorithm which I wrote using the inbuilt libraries. This one is the expanded approach of that same algorithm. Now let's run it and see how it performs. But before that, one thing that we also noticed we need to do is we need to add our characters that are there in the ransom node which are not present in the magazine. So we'll also add that in our original character set of magazine so that we can have those character available to us during the time of calling and comparing the two sets together. So that will do, and now let's run our solution and see how it performs for all the use cases. So this is CNT, and so there is no character in B. Okay, so we have applied this on all the character string. So we need to add one condition that our character should only be in the ransom node set as well as in the magazine set that we created. So we should not get this B error for different test cases because this character B is not present. So it failed in the test case number A, and B. So here B is not present in the original ransom node. So that's why it gave us the error. So now I have added the condition to check that character should be in both uh, set that we declared. So now let's run our solution. So now this has been accepted, and let's submit our code and see how it performs for all the use cases. So it has been accepted and it's pretty fast. So the time complexity for this is straightforward. We are using O of M in the magazine. So there are M characters in the magazine set. So that's O of M. And similarly, we are using N characters in the ransom node. So that would be another O of M plus N, because here we are adding that N characters of N of random set into the M. So that is the time complexity. And the space complexity is we are all using all the 26 characters. So O of 26, which is basically O of constant. So which in turns out to be O of 1. So we are not using any space as such. This is the same idea that I showed you using both the inbuilt functions and the counting algorithm. So I hope you like this solution. And one more thing I was thinking about, like, can we do it using any other algorithm? So I came up with one more algorithm, that which my approach to, that we can only use hash table to solve this problem. So what we can more do is we can create just one set of magazine, and why don't we check these characters that are in magazine with the ransom note. So what we'll do is we'll just traverse in the ransom note string that we have, and we'll see that if this character is present in the ransom note, then what we'll do is we'll decrease its count by 1, so that we get the idea that this character is present in my character set of magazine. And as soon as we reaches a value below of that particular character in the below 0 in that in the magazine set that we declared, will immediately return false, and otherwise will return true. So this is the second approach which I came up with. So that has also been accepted, and let's submit this and see how it performs. So this algorithm is faster than the first that we declare that we write. So this is the two approaches and that I come up with for solving this problem. So I hope you guys have liked my solution, and if there is any particular problem that you want me to solve, please let me know, and I will see you tomorrow with some new algorithmic solution for new algorithm problems. Thank you and have a nice day.